Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on how to find the empirical formula of a compound. Alright, so the way in which we calculate empirical formula is by following this little rhyme. Percent to mass, mass to moles, divide by small, multiply till whole. So percent to mass is we just assume that there's 100 grams of compound, and so whatever the percentage is, that is the same as our mass. So if we have 80% carbon, we have 80 grams of carbon. If we have 20% hydrogen, we have 28 grams of hydrogen. To turn mass into moles, we divide by the molar mass of our element to get to moles, and then once we're at moles, we need a whole number ratio, so we divide by the smallest value. If that doesn't give us whole numbers, then we look at what decimal we have, and then we either multiply by 2, 3, or 4, depending upon what that decimal is. Okay, so let's get started. So here we have a compound that contains carbon and hydrogen, and those are the only elements that I have. So I have 74.8% carbon. That means that I have 74.8 grams of carbon. I have 25.2% hydrogen, which means I have 25.2 grams of hydrogen. All right, so we did percent to mass. Now we're going to do mass to moles. So I'm going to divide each one by the molar mass to get it into moles. So the molar mass of carbon is 12.01 grams, and the molar mass of hydrogen is 1.01 grams. So grams will cancel with grams, and I will be left with the unit of moles. All right, so we'll do this math, and I'm going to get here 6.228 moles of carbon. Usually when I do this, I like to round to at least 3 decimal places so that when I divide in the next step, I get the most accurate answer possible. All right, so 74.8 divided by 12.01, we said was 6.228, and then 25.2 divided by 1.01 is going to be 24.950. All right, so now I'm going to divide by the smallest value. So this gives me 6.228 and 6.228. All right, so I divide by the smallest value to get whole numbers. If I divide by the larger one, then I'm going to get some of my answers could be fractions, and I don't want that. And then I do that to everything because what I have here is a ratio of the moles of carbon to the moles of hydrogen in my compound. And to keep the ratio the same, whatever I do to one of them, I have to do to the other one as well. All right, 6.228 divided by 6.228 is 1, so I have 1 carbon. And 24.50 divided by 6.228 is 4, so I have 4 hydrogens. All right, so that means that my formula here is going to be CH4. All right, let's do another. Here I have a compound that contains potassium, chromium, and oxygen. All right, so my potassium, I have 26.6%, so I have 26.6 grams. Chromium is Cr. I have 35.3%, so that's 35.3 grams. And oxygen is 38.1%, so 38.1 grams. All right, so now I divide each one by the molar mass. So potassium is 39.1, chromium is 52, and oxygen is 16. So now when I do that math, I get 0.608680 moles of potassium, 0.679 moles chromium, and just 2.381 moles oxygen. I just put oxygen as oxy so that we don't get it confused and think it's a 0. All right, so I did percent to mass, mass to moles, divide by small. So the smallest one here is 0.679, and I'm going to divide all of them by 0.679. So this gives me 1K, 1 Cr, and 3.5 oxygens. So now I have 1, 1, and 3.5. So 3.5 needs to become a whole number. So the decimal 0.5 represents 1/2. So if I need to get rid of 1/2, I can multiply by its reciprocal, so I can multiply by 2. So I'm going to do times 2, times 2, times 2. I have to multiply all of them by 2, otherwise my ratio won't stay the same. So now I have 2 potassium, 2 chromium, and 7 oxygen. So my formula here is going to be K2Cr2O7. Awesome. All right, let's do another one. So here we have glycerol that contains carbon, hydrogen, and oxygen. So this time I have 3 elements. So carbon is going to be 39.12 grams. Hydrogen will be 8.77 grams. And oxygen will be 52.11 grams. So now I'm going to divide by molar mass. Carbon is 12.01. Hydrogen is 1.01. And oxygen is 16. All right, so we do the math on this, and we get for carbon 3.527 moles. For hydrogen, we get 8.683 moles. And for oxygen, we get 3.572 moles. All right, and then we divide by small. So the smallest one here is 3.257. All right, and now we do the math, and we get 1 carbon, 2.67 hydrogens, and 1 oxygen. Okay, now I have 1 carbon, 2.67 hydrogen, and 1 oxygen. So I need to get rid of this 0.67. 0.67 is 2/3, so if I multiply by 3, that will give me whole numbers. So times 3 gives me 3 carbon, times 3 gives me 8 hydrogen, and times 3 gives me 3 oxygen. So when I write this as a formula, I get C3H8O3. Hooray and huzzah. Okie doke. Let's look at another. So here we have a compound that contains carbon, hydrogen, and oxygen, but it only gives us the percentage of carbon and the percent of hydrogen. So this is not a problem. So if we know how much carbon and hydrogen we have, we know that our total percent composition has to equal 100. So if I do 100 minus the amount of carbon minus the amount of hydrogen, then I should get the percent of oxygen. So this is going to be 59.30% oxygen. So now I have all the information that I need. Carbon is going to be 35.48 grams. Hydrogen is going to be 5.22 grams. And oxygen is going to be 59.30 grams. All right, now we divide by molar mass. Then I'm going to do the math. So when I do this math, I get 2.954 moles of carbon, 5.168 moles of hydrogen, and 3.706 moles of oxygen. Now we divide by small. So when we do that, our small value is 2.954. So we'll divide all of them by 2.954, and I get 1 carbon, 1.75 hydrogen, and 1.25 oxygen. So I look at my decimals here. 0.75 is 3/4, 0.25 is 1/4. So since they're both over 4, I can just multiply everything by 4. So I get 4 carbons. 1.75 times 4 is going to be 7 hydrogens, and 1.25 times 4 is going to be 5 oxygens. So my formula here will be C4H7O5. Okay? Let's do a couple more. So here we have a compound that contains only vanadium and sulfur. So this is relatively straightforward. 5.1 grams of vanadium and 48.6 grams of sulfur. Divide by the molar mass. Vanadium is 50.94 and sulfur is 32.06. So we do this math and I get 1.009 moles of vanadium and 1.516 moles of sulfur. Now we divide by small. 1.009, 1.009, and I get 1 vanadium and 1.5 sulfur. Again, 0.5 is half, so I multiply by 2, and I get 2 vanadium and 3 sulfur. So I get V2S3. Okay? All right, let's do one more. So here we have a compound containing sodium, sulfur, and oxygen. So we have the percentages of sodium and the percentages of sulfur, so we need to find the percent oxygen. We can do this the same way that we did before. It's got to be out of 100, so I subtract the amount of sodium, and the amount of sulfur, and I get 30.36% oxygen. And now I have everything I need. Sodium is 29.08 grams, sulfur is 40.56 grams, and oxygen is 30.36 grams. All right, so I'm going to divide each one by its molar mass. Now I do the math. This is going to be 1.265 moles of sodium and, surprisingly, 1.265 moles of sulfur as well. And then the oxygen is 8.98. And then we divide by small. So 1.265, 1.265, and 1.265. I get 1 sodium, I get 1 sulfur, and I get 1.5 oxygens. So again, 0.5 means I multiply by 2, which is going to give me 2 Na, 2 S's, and 3 O's. So my formula here will be Na2S2O3. Okay, so this is how we find the empirical formula of a compound. If you're looking for how to find the empirical formula of a hydrate, that is in the hydrates video. All right, this has been another episode of Chemistry with Wikipedia, tutorial edition. I hope you learned something, and until next time, keep on chemin'.